Hello everyone. Let's take a look at our next problem. Integrate x sine squared x. So my first instinct here is to do integration by parts. This is something when I differentiate it, it goes down in a power, but I'll have to look up how to integrate that, or alternatively, there's a trig identity where we can write this in terms of a trig function without an exponent on it, and it'll be easier to apply integration by parts to that, because then I'll be able to figure out a direct integral. So first thing I need is I want to figure out what the trig identity is to write sine squared x in terms of a trig function without an exponent. I don't have this one memorized, so I'm going to do it like this. Okay, so I've got cos squared x minus sine squared x is equal to cosine of 2x. This is the thing that I'm looking for, and I'm going to replace cos with 1 minus sine squared x. All right, and if I substitute this back into my original integral, I have x over 2 dx minus the integral of x cos 2x divided by 2 dx. This is straightforward, and this now looks a lot better to apply integration by parts to, because I can differentiate this and the power goes down, and when I integrate this, well, I know how to integrate that in closed form. Okay, so let's write this as x squared over 4 minus the integral of x cosine of 2x over 2. Okay, so I've just done that integral directly. And now I'm going to treat this integral as its own little intermediate problem that I need to solve here. Okay. Yeah, so when I differentiate this, I get cos 2x times 2, and that extra multiple of 2 will cancel with one of the multiples of 2 there. All right, so this integral is equal to x sine 2x over 4 minus the integral of sine 2x over 4 dx. I'll put the plus c in later because I remember there's a negative sign up further up there that we'll have to take into account, but it's not going to really make a difference on things. So let's just make sure I don't have a sign error or something like that here. When I differentiate this, I get sine 2x with negative sign and an extra factor of 2, which will cancel with that to get a 4. Okay, so this is correct. And so the original integral I'm looking for here, what did I have before? X squared over 4 minus this integral, and that should be it. Okay, we should be able to check our answer by differentiating here. So let's go ahead and do that. Some cancellation of those terms, that's kind of expected. So I get x times 1 minus cosine of 2x divided by 2. And assuming I derived my original trig identity correctly, this here is the same as sine squared x. I'm pretty sure that's correct. So yeah, we take a derivative of our conjectured answer, we get back the original function we're trying to integrate. Shows that this is correct. Pretty straightforward overall. Recognizing right away that something looked like integration by parts would work, but then realizing that applying integration by parts directly to this would be a little bit messy. But I know that there's a trig identity which allows this to be written as just a sinusoid rather than the square of one. And I know this is going to be a form of integrand that allows integration by parts to be applied much more easily. Thanks for watching.